Okay, so let's create some formulas for this question. Relative velocity 2015, question 2. Part B. A woman falling vertically by parachute in a steady downpour observes that when her speed is 5 meters per second, the rain appears to make an angle of 45 with the vertical. Okay, let's do a little diagram. She's falling. She's very observant, this woman. She can see a lot going on. So she's falling at 5 meters per second. The rain appears to make an angle of 45 with the vertical. I'll just continue this down a little dotted line. So the rain appears to make an angle of 45 here. So this is the velocity of the woman, just here. The velocity of the rain relative to the woman is going down this way. So this must be the velocity of the rain. So let's create some equations here. The velocity of the woman is equal to, it's just going down in the j direction, so 0i, nothing happened in the I, and she's going down, so it's minus 5j. If we look down here, we have my I direction, so opposite actually doesn't matter in this case because it's 45 degrees, but we'll keep it consistent. So the velocity of the rain relative to the woman is equal to, well, let's call the speed u, and let's look at the direction. It's coming down this way, so we're going out on the x, or out on the I and down on the y, so it's positive, negative. So it's going to be, well, let's call it u. I think we called it u the last time we did one of these questions. So we're going to have u cos 45. No, is it u sine 45? My bad. It's opposite to 45. It doesn't matter in this question, but let's do it correctly. I is opposite this 45 degrees here. So u sine 45 times I, and it's minus u cos 45 because it's adjacent. J is adjacent to the cos 45, so times j. So that would give us, we know 1 over root 2 is the sine and cos of 45, so u over root 2 times I minus u over root 2 times j. Okay, so they're the black ones. Let's have a look at the blue part here. When our speed is 3 meters per second, the rain appears to make an angle of 30 degrees with the vertical. Find the magnitude, which we know the magnitude and direction of the velocity of the wind. Okay, let's look at the blue. Let's do a blue diagram. She's falling this time. Let's try and do a straight line. She's falling at 3 meters per second down this way. Velocity of the one. The velocity of the rain appears to make an angle of 30 degrees. We'll look at our I and j now in a minute. 30 degrees with the vertical. So in there, and the velocity of the rain coming down this way. So the velocity of the woman is equal to 0i minus 3j. The velocity of the rain relative to the woman is equal to, so in my I direction, we're opposite to 30. So we call the speed v this time, and again it's going the same direction as positive, negative. My I direction is opposite to 30, so sine, so v sine 30 times I minus v cos 30 times j. And what does that simplify to be? Sine of 30 is a half, so v over 2 times I, and the cos of 30 is root 3 over 2, so minus root 3v over 2 times j. So let's look at the velocity of rain in each case. The velocity of the rain relative to the woman is the velocity of the rain minus the velocity of the woman. So the velocity of the rain is equal to the velocity, we're going to add these two together, rain relative to 1 plus the velocity of the woman. So the velocity of the rain in black is these two added together. So we have u over root 2 plus 0 times I. So u over root 2 times I. And we have minus 5 minus u over root 2 times j. Minus 5 minus u over root 2 times j. In blue. We're going to add them together. So we have v over 2 times I. And we have, put a plus in, I should put plus in here too. Plus, and in a bracket, we have minus 3 minus root 3 over 2 times, put my v in, v times j. Okay, so we have two equations now for the velocity of the rain. So we have two unknowns, two equations we'll be able to solve. So we can equate the I, guys. V over 2 and u over root 2 must be equal. V over 2 is equal to u over root 2, which would mean that 2u, if I got that right, yeah, 2u is equal to root 2v. So u is equal to root 2v over 2. Okay, let's look at the other side of this equation. We have this guy is equal to this one. So minus 3 minus root 3v over 2 is equal to minus 5 minus u over root 2. So that's this guy here. We've replaced the u here with root 2v over 2, root 2v over 2 divided by root 2. Okay, so if I divide top and bottom here by root 2, they'll cancel for me. So I'm left with 2's on the bottom. Let me multiply by 2 to get rid of them. So minus 6 minus root 3v is equal to minus 10 minus v. So the root 3v I'll bring to the right and I'll bring to 10 to the left. So 4 is equal to root 3v minus v. So this will give me a solution for v. 4 is equal to v times root 3 minus 1. So v is equal to 4 over root 3 minus 1. Now we type this into a calculator. 4 divided by root 3 minus 1 gives 5.46. And how will that help me? Well, v over 2 is the I component. So v over 2 is equal to 2.73, and that's the easiest way then to get my j component. J component is, well, I've got v, so I'll use this one. So when we put our v into this guy, we're going to get minus 3 minus root 3 by 5.46. Just that section of it divided by 2, and if I type that into my calculator, it's coming up as minus 7.728. So we take minus 7.73. So the velocity of the rain is, what do we get? We get my v over 2 component, 2.73 times I, and we have a minus 7.73 times j. So the magnitude and direction is the square root of 2.73 squared plus 7.73 squared, which works out to be 8.2 ms to the minus 1. And the angle, the inverse tan of 7.73 divided by 2.73 gives me 19.5 degrees, and that would be with the vertical. So that's that question complete.